All right, guys, and we are back. And now today we are going to continue with chapter 9, which is color perception, okay, and Color My World, as he had called it in our class. Now, guys, I wrote down quite a bit, so I'm going to try to get through this as quickly as possible. Pause, go back, write things down. I would just recommend doing that, or if like the little transcript thingy pops up, maybe you can use that. I have no idea. Anyways, our boy Isaac Newton, write Newton down. He had the prism, right? And everybody thought, oh, you can't divide white light with a prism. No, you can't do that, boy. And he's like, think again. You can divide white light, okay? And with that, you divide the light into our visible spectrum, okay? That is the spectrum, that is the color with our cones and our eyeballs, those receptors, that is what we can see, okay? So light is divided up into different wavelengths. We have blue with our short wavelengths, medium, green in color, and then you have red with our long wavelengths, okay? And so yellow is kind of awkward because it's a mix of like medium and long, okay? But we're going to get to that with color mixing in a second. So we went over our cones that see color. What do the rods see? They only see in value. They only see in lightness and in darkness. It's black and white. That's it. Like when you turn off the lights in a room, what's going to be activated? My rods. My cones will not be in action. I will not be seeing anything with color or anything to do with visual acuity and my detailed vision. I won't be seeing that, okay? Okay, colors. Okay, the reflectance spectrum. What do objects do? How can we see objects in color? The objects are reflecting the light back at our eyes, okay? That's how we're seeing things. Remember that white is reflecting all the colors. That's why we can't see anything. It's just the prism. It's white light. Black is taking all the colors. It's absorbing all of it. Just like Mando, okay? He is in a dark area, right? So he would only be seeing with his rod vision or, in black and white, lightness values, okay? So speaking of value, guys, what are our three components with color theory, okay? Hue. What is hue? AKA color. What is saturation? Saturation, that's intensity. How light, how dark is my color? Is it super red, like Marilyn Monroe, like cherry red lipstick? Or is it super dull? Is it like a gray? Is it super faded and washed out, right? So my intensity is my saturation, my hue is my color, lightness is value, again, like our rod vision, okay? What else do we have here? The color dress, that was a huge thing that he had mentioned, that in cold weather, we have a lot of reflected blue light on our short wavelength on our visual spectrum, right? When you see a dress in that bluish lighting, it's going to be gold underneath. It's going to have that gold color, if we remember the hashtag the dress from our textbook. And then that warm yellow light, what are we going to see? The dress is going to be seen as blue because you're going to have warm colors all around you. Okay? Another thing with color preference really quick, Palmer's experiments, he associated with positive experience, guys, that you're going to have a certain color preference, okay? So if I have the USF Bulls, for example, green and gold, if I really am positively associating my experiences with those colors, that's going to be the preference that I have, are going to be those colors of green and gold, okay? A little bit on the opponent processing theory with Hearing, I think that's how you pronounce his name. It's Hering, if you want to add that name. He had our two different opposing colors. You think like a boxing match, you're going to have red, you're going to have green, you're going to have blue and yellow. Those are going to be your opponent's cells, okay? So those can either be shown really positively or really negatively. Those are interchangeable. They're kind of like contrasting colors in a way. Let's see, anything else? The trichromatic theory, that is with Jung. You may want to write that down as well. talked about black and white, the reflected spectrum with objects. Oh yeah, color mixing really quick. I don't know if this is going to be on there, but if you're mixing pigments, okay, you are mixing like, you're mixing the wavelengths, right? But it's going to be subtractive. That's subtractive color mixing. So I'm mixing yellow and blue like from our textbook. And if I mix them together, the only wavelength that's going to survive that mixing is the medium wavelength of green, okay? But if I'm mixing light, for example, it's additive. I'm going to be adding things in, and that's why you're going to mainly get white light. It really doesn't matter if I'm putting all the colors together, right? That's going to be white light, okay? Just like with the prism, all the colors together, it's white light. But if I divide my prism, it's all the wavelengths of the visible spectrum, okay? So that's pretty much it. Thank you guys. That is going to be chapter 9. That is the main topics from the lecture with color perception. Our last videos are going to kind of combine chapter 10 with size and depth perception and the infant experiments, okay?